guys, we are going to jump into this homework. Sorry it's taken me so long to get this uploaded, but here we are. We're going to do it now. Okay, so on your 3-9 homework, problems numbers 4, 5, 6, and 7, I'm going to walk through with you on these. And, each problem is a little bit different. The approach to the problem is always the same. So as you can see, this is number 4. And the problem reads something like this. An angler hooks a trout and reels in his line at 5 inches per second. And so we're going to go through and, you can fill in the blanks with your problems and see if that helps. But here we go. So an angler reels in on the problem I'm working on, it says 5 inches per second. It says assume the tip of the fishing rod is 13 feet above the water and directly above the angler. And the fish is pulled horizontally directly toward the angler. And it says see the figure. So the fish is going this way. The line is going this way. Okay? And it says find the horizontal speed of the fish when it is 23 feet from the angler. Now, first of all, I noticed, and this is something that you just have to get in the habit of noticing, that one measurement is in inches and one measurement is in feet. And so you need to pay attention to the problem to find out which one you want your answer in. So as I look down, I'm going to have my answer in inches. Now, you may not know this until later on in the problem, but I'm giving you a heads up. You're going to need your answer in inches. And so if 13 feet is going to be converted to inches, and so we just multiply 13 times 12, which is, I'm not mistaken, is 156. And again, 23 is going to have to be turned into inches as well. So I've got to do 23 times 12, and I don't know what that one is. I'm going to have to do a little figuring. I'm getting 276 for that one. Okay, so these are my numbers for this particular problem. My Z is decreasing at 5 inches per second. So since it's a decreasing, this one's going to be a negative in my calculations. Okay, so now these two lines, the red arrows, those are the things that are moving. Those are moving. This one right here, the rod, is 13 feet, also known as 156 inches, and it's not moving. It is constant. It is not changing. Okay, remember the derivative of a constant is 0. Okay, but these two over here, these are moving. All right, so this is a right triangle, and so I'm going to work with right triangle stuff. These are right triangles. And the first question says, let x be the horizontal distance, so it's telling you this one needs to be your x, and z be the length of the fishing line, so it's telling you this one needs to be z, and both x and z are measured in inches, so that's why we had to come up with inches. All right, and it says write an equation relating x and z. Well, I had called this other one y, and I'll show you how I did this problem. Okay, so technically I use Pythagorean theorem, which would say that x squared plus y squared is equal to z squared. So I would say x squared plus y squared is equal to z squared. But in this problem, y is constant. It is going to be 156 no matter what. And so this is the equation that goes in your first blank. This is an equation using x and z, and it's in inches. So that's the first one. And now this, we're looking for rate of change. We're finding the horizontal speed. Okay, and horizontal is this way. So we are technically looking for dx dt. That's what this is. We are looking for dx dt. Okay, that's speed. That's the rate of change. Speed, rate of change. So we're going to take the differentiate. We're going to differentiate both sides of this equation. 2x dx dt. Now remember, what's the derivative of a constant? 0. And then 2z dz dt. Okay, now what is dz dt in this problem? Well, this is the rate at which the z is changing, and the z is changing at a negative 5 inches per second. This is your dz dt. Okay, and so that's the derivative that we're dealing with. Now, the instant they want us to do this, okay, the instant that they want to do this, I'll get to you in just a second.